Now let's go and do the third method of finding R Thevenin, this time with the short circuit current and the open circuit voltage. Okay, and notice that let me just go ahead and write on here that the open circuit, just a reminder that VOC is V Thevenin, and we already found V Thevenin, which is, as I mentioned, is sort of a handy thing to do. Okay, now what we're going to do, I'm going to draw the equivalent circuit on here of what this looks like. Now, this equivalent circuit will, in this case, look like the Thevenin equivalent circuit, where this is VOC. We actually already found that. That's V Thevenin. That's 20 volts, right? We've already found R Thevenin. In the other cases. Now, we're actually going to find R Thevenin in this example, but we already know it's 6 ohms, but we'll verify that it's 6 ohms in here. And what we're going to do is then short the port here, and that current is going to be ISC. Okay, and again, so in this case, realize that R Thevenin, if we were going to just sort of write down the equations here, remember that R Thevenin in this case is equal to VOC over ISC. Okay, and I guess I should have drawn that in purple. Let's do that in purple here. There's VOC. All right, so so note that the steps here. Step 2, we're going to leave all the sources on. So you can see here that we've left the 5 amp current source on. Step 2, we're then going to short the port AB. So let's go ahead and do that now. Okay. And I draw that as a curly wire because it reminds me that it's not a regular circuit wire. It reminds me that it's a wire I put there intentionally to short the port. And then we're now going to find ISC. All right, so that's the third thing we want to do, is find ISC. Okay. So let's recognize the fact that, let's address the fact that ISC is the current that's flowing through the short wire, but it's also flowing all the way through that 2 ohm resistor on the right there as well. And then let's also acknowledge the fact that we're going to place a ground right here. And so if we found this node voltage there, and we divided that by 2 ohms, we would then have ISC. All right, so what that means is that we need to know that node voltage. I'm going to label these nodes again. This is Vx with respect to ground, just like we did last session. This then is 3Vx, like we did last section, because if this is a Vx here, and then there's a plus 2Vx across that dependent source, then doing a mini KVL or a mini walk, this node must be 3Vx. It's 2Vx higher than the Vx node here. Okay, so now what we're going to do is we'll recognize that that is a supernode. And so we're going to do a nodal analysis at the supernode Vx and 3Vx. This is going to look super similar to what we did on the other sessions of the other techniques, except that now there's a 5 amp current source coming into the supernode on the Vx side. So let's go ahead and do that. So we've got 5 amps coming in, plus still on the Vx side, there's a 0 minus Vx over 4, plus now on the 3Vx side, we've got a 0 minus 3Vx over, now what I'm going to do is note the fact that the 6 ohm and the 2 ohm resistor share, both of their nodes are connected to the same terminals. So they share the 3Vx node here at this point, and then they also share ground on the other side. So they are in fact connected in parallel, right? So the current flowing from, between the 3Vx node and ground is flowing both through the 6 ohm and the 2 ohm. If we were drawing it like far minus near, we would think of it as coming up from ground and coming up from ground that way. But I'm going to treat that path, that whole current path, as flowing through the 2 ohm and the 6 ohm in parallel. Okay, and all of that is equal to 0. All right, if you then isolate for Vx and move the Vx terms onto the other side, you'll get that Vx times a quarter plus 3Vx, 3 over 2 parallel 6 ends up being 1.5 ohms, is equal to 5 amps. And then if you solve for Vx, you'll find that this is 5 over 2.25, which is 2.22 bar volts, which gives then the 3Vx must be 3 times that amount, 6.66 bar volts. Okay, now that we have the Vx, the 3Vx term, we can find ISC. And ISC is just 3Vx over 2 ohms, right? It's the current flowing through that guy down to ground, or in other words, 6.66 bar volts divided by 2 is 3.33 bar amps. All right, so now when we finally go through and do R Thevenin is equal to, again, it's VOC over ISC. We already have VOC is 20 volts. We found that much earlier at the first step of this problem on Tuesday. And then this is divided by 3.33 bar amps, which gives an even 6 ohms. And so there we have now completed Thevenizing the circuit by finding ISC, the short circuit current, and then taking VOC, the open circuit voltage, divided by ISC, and that gave us our Thevenin.